Alright, our second graphing one, not quite as straightforward as that last one, but we can still rock it. What do we know? Well, we know our y-intercept is at 0, comma, negative 13. Let's pull a negative 3 out, and what do we have? Y equals negative 3, pull that out, we're left with x squared. Negative 18 divided by negative 3 is a positive 6, so I have a plus 6x right there. I'm not going to pull a negative 3 out of a negative 13 because that's gross. So I'm going to leave that there. That's telling me I'm not going to have nice x-intercepts, but that's okay. So why don't we complete the square and identify the vertex? So to do so, y equals negative 3 times x squared plus 6x. Well, that's going to complete as x plus 3 squared. I still have my minus 13. Now I need to adjust. That plus 3 right there, that's giving me a plus 9 on the inside of those parentheses, which is being multiplied by a minus 3. So 9 times a negative 3. I have affected this equation by essentially subtracting 27, and so I need to add 27 to balance it. Cool, cool, cool. All right. Well, let's simplify this. Y equals negative 3 times x plus 3 squared. 27 minus 13 is what? 14. So plus 14, right like that. So what does this look like? Well, I found my vertex. My vertex is at negative 3, because of that x plus 3 right there, negative 3, comma, 14. Okay, so that tells me that my axis of symmetry is at x equals negative 3. Notice that my a value is negative, which means that my parabola has been flipped upside down, which means it has a maximum value at the vertex. So I have a maximum at negative 3, comma 14. What else are we interested in? Domain, again, we already said that our domain is going to be all real numbers for every single parabola ever. So let's say x is in the interval going from negative infinity up to infinity. Range, how are we going to do that? Well, range is going to be, notice I have a maximum value at the y value of 14, which means my graph can be everything below 14. So I can go, I can go all y values in the interval going from negative infinity up to that maximum value of 14. But I can include that value, so that should be a bracket right there. Okay, well, let's sketch this graph, and we need to include at least 5 points. We know the maximum value is 14 up here. So let's start with that. Let's go 1, 2, 3, 4, 5, 6. I'm not going to do a scale on my y-axis. I'm going to label points instead. So my vertex, what do we say? Negative. Oh, whoops, it's negative 3. So 1, 2, 3, 4, 5, 6. That way. Negative 3, 14. So let's go negative 3, 1, 2, 3. Let's say my vertex is right there at negative 3, comma 14. Alright, well that means my axis of symmetry is going to be running right there. What other points do I know? I know that my y-intercept is at 0, negative 13, so about that same distance now below the x-axis. So about right there, there's my point 0, comma, negative 13. Notice how far over I am from the axis of symmetry. I'm 1, 2, 3 to the right of it. So if I go 1, 2, 3 to the left of it, I should have another point right there. So that point has to be negative 6, comma, negative 13. Right there. So let's just show 2 more points. Easiest way to do that is going to be to show 1 point over from the vertex, because my a value is negative 3, which means if I go 1 point over like that, I should be down 3. So that's going to be negative 2, comma, 14 minus 3 is 11, and then negative 4, comma, 11. So nice, straightforward way to get those points right there. And now we can Sketch that in. And there we have it. Think about other way you could have found your axis of symmetry. You could have done negative b over 2a, which means negative b, well, b is 18, negative 18, so negative b is positive 18, divided by 2 times a is negative 3, right there. If we simplify that, 2 times negative 3 is negative 6, so 18 divided by negative 6 is in fact negative 3, the value we found by completing the square. Cool. Alright, so there's all of that information, and we sketched our graph, and it looks pretty good, and we're going to call that good.